Back of your spirals, 3 problems, no X. See what you can do. If you don't like number 1, think of it as 2 over 1 over 3 over 5. If you don't like number 1, you can think of it as 2 over 1 divided by 3 over 5.
Oh, okay. So it's 3 over 10? Like section 1 and 2, I think.
Alright, you guys close?
Yeah.
For how many of you guys did 2 over 1 help? 2 over 1? That's 2 over 1 over 3 over 5. That was the hint I gave you over there. Yeah. This one you can do 4 over 1.
Wait, no.
Maybe forget it. Yeah, I know. They should be reading
Got it.
Rich,
Tyler. Tyler.
okay.
I got it with 2 left. 2 seconds to spare.
It was the
I got the shout.
You guys are so picky. I don't know if you can change the sound. You're fine. Alright, why did I say 2 over 1 over 3 over 5?
Division is multiplication, but reciprocal.
Multiply by the flipper. Hey, that's nice. You guys probably don't know what flipper is. It's a TV show with a dolphin. Anyway. This is the same era as Gilligan's. No,
Was it animated or?
No.
How did it?
It was real people. Because you can train dolphins. There was like an actual dolphin and they were like in Florida.
Was the dolphin actually talking? I mean, like, was there?
No, it was interacting with the people.
Oh, that's okay. I thought it was like
Free Willy or something.
Like, Space Pops.
Is that
Is that
two?
those movies where they made the dolphin?
When you divide, you multiply by the reciprocal. Are we tracking?
10 over 3.
So you end up with 10 over 3. Now hold on. There is a shortcut for complex fractions. There are actually a couple of them. There is a shortcut for complex fractions. There are actually a couple of them. One shortcut that I have seen people come through with is top the outers over the inners. Think about it. You see it? The outers, 2 times 5. Over the inners, 3 times 1. But there's also my trick, which might be a little more useful for algebra. That just depends. But I'll show you my trick in the next problem. Okay? So hold on. You guys should know from the outers over the inners. What's the answer to number 2 without doing anything? 1 times 2 over 3 times 5. So it'll be 2 over what? 15. Some of you already solved it. So let me show you my trick. Now you could have to write out this whole 1 over 3 times or divided by 5 halves, which is times 2/5. But the other way that you could do it is, besides the outers over the inners, you could multiply top and bottom by the common denominator. What would be the common denominator of 3 and 2? 6. So you could multiply top and bottom by 6. And if it helps, you can do 6 over 1. What do you get on top? What's 6 over 3? 2. What's 30 over 2? Does it work either way? Yeah. You can multiply top and bottom by the common denominators of the numerator denominator of a complex fraction. You can do the outers over the inners, or you can do our snazzy 1/3 divided by 5 halves is 1/3 times the reciprocal 2/5 and then go from there. Now how? I have no idea. How?
Just get up and get it, man.
If I go get it, you'll feel really good. Okay, so number 3. Why is it a little bit harder? Have you guys common denominator just for the top? Wait.
It just jumped on
Wait.
the desk.
How would you have had to do this in like Algebra 1? What would they have you doing? Algebra 1? Oh, you have to get common denominator. Because remember how you'd have to write the numerator divided by the denominator? You have to get it to
Oh,
the
I did do that. Actually, I just didn't do that exactly. Yeah, I did 10
So it'd be
fifths.
10 fifths minus 2 fifths would be 8 fifths all over 4 over 1. You could write it division of 4 over 1 is
We
multiplication
did
of 1
that. We
over
just
4.
didn't know what we were doing.
However, can we try you could also distribute the 1/4 into both pieces and then put it together or keep it separate? The simplified answer would probably be 1 fraction. Does that make sense? Or 1 term. However, what if we were to use my trick? My trick is multiply top and bottom by the common denominator. Wait, how many denominators within the complex fraction are there? Just 5, right? Think about complex fractions. What's the 4 over 1? No big deal. So my trick would be, okay, multiply top and bottom by 5. Why is this legal? Because I'm multiplying the same top and bottom. Yeah, I'm multiplying by 1 creatively. What happens on top? What's 5 times 2? 10. Minus. What happens when I go here? Right? It cancels out. Hold on. I'm trying to figure out how to show this. Because right now it's illegal. Okay, so when I distribute that in, there we go. The 2 times 5 stays, it's 10. The 2 over 5 times 5, the 5's cancel, I just get 2 all over, what's 4 times 5? Look, complex fraction is gone. I didn't worry about a common denominator. I didn't worry, like inside the fraction, I didn't worry about multiplying by the reciprocal. I didn't have to worry about outers and inners. I just said, I don't like that little denominator. Let me do something to get rid of them. Oh, easy. 8 over 20 reduces to be 2 over 5. So, the reason I like my trick is it says, ew, gross, little denominators inside a fraction. Let's get rid of them. And so it turns it into, ew, let's get rid of them. Oh, that's nicer. Ew, let's get rid of them. Oh, that's nicer. However, are there other ways of dealing that you guys have been learning, I don't know, for the last few years and practicing? Yeah. So you do whatever way works for you in the sense of, or the sense that. You could technically show the work by division is multiplication by the reciprocal, etc. You could technically do like what I did, 2 over 1. You could make it 4 over 1. You could do the outers and the inners, just so you have to make sure you're keeping it legal. Does that make sense? Question though, why on earth am I doing this formula? Back to your notes. And as you get back to your notes, figure out what on earth section 5.2 is about. And as you're looking at what section 5.2 is about, let's reorient with the calendar. Technically, this homework was supposed to be due tomorrow. It's a doozy. And I really want you to take your quiz on Thursday when I'm gone. So, instead of the quiz being Wednesday, the quiz is Thursday. There's homework being due tomorrow. It's due Wednesday. Everything is moved today. We have more time to do examples. It was nice with chapel days, a little bit shorter anyway. So, we're continuing on 5.2 today. We're finishing any other examples I want to do tomorrow, / getting questions that you guys have up to the board / working together maybe on some homework where you got stuck. Now question. Tomorrow, second half of class, if you start your homework, is it going to be a doozy?
Yes.
Yeah. It's going to be a little bit brutal. But if you start tonight, you get stuck, you come tomorrow, you have half a class to work with the people in your group and or me. Maybe not too bad. Maybe have it done pretty quick.
Hopefully.
Maybe be more ready for the review on Wednesday and ace the quiz on Thursday? Hey, we can always hope, right? What were we doing in section 5.2, guys? Wait, what? Oh my goodness, it doesn't look at all the same. Not until maybe we get to something like, well, something like this. What? What on earth does this one have to do with what we were just doing? start here. We'll go back to the other example in a second. Let's start here because it kind of shows why I did that warm up in the back of your spiral thing. Write down the problem. The directions are verified. What does that mean? They say it's true all the time, right? Not just conditional. We're not solving for theta. It's true. They're telling me it's true all the time. It's an identity. It's an identity. True all the time. Oh, that's right. We had specific steps we had to go through in order to solve this, and I give you a half point just for starting the right way. What's the right way to start? Make a T and choose a side. Good. Make a T and choose a side. And my advice was choose the more complicated side. So the right side, right? The right side, what we do? 1 over cosine. It doesn't match. We're stuck. Oh. Let's not do that. But we make our T. Let's put it over here. Wait a minute. How do you show me you're choosing the side? How do you finish getting that first half point?
Put it down.
Right. Why? Some of you will start plugging in right away or crossing out stuff right away or doing stuff, and so then you don't know what was really there to begin with without going back to your book and re-looking at the problem. So I want you to have a nice, clean copy of the problem before we start working. So we're keeping that one, we're not touching them at all, and we're going to go ahead and rewrite him, and this is our working copy. This is kind of like our master copy. Here's our working copy. All right. We have options. And I think via the steps that we were talking about on Friday, you guys should have had those written down. We shortcutted them a bit. Either we start with math, if there's something to do, factoring, dividing, multiplying, subtracting. If there's something to do, we start with math. If there's nothing to do, we better start with plugging in a property. What properties? Hold on. Go to 5-1. Go to 5-1. Go to the beginning of 5-1 notes.
Cosine of u.
Just to remind us, that whole table. What was my advice for the whole table that you guys start doing so you have it with your homework and you don't have to go flipping through notes? Memorize the formula is true, but remember for the test, which is not this week, this week's a quiz on just 5-1, 5-2. Next week or the week after is the test. There's going to be a formula portion, but once you get to problems, are you going to have to remember the formulas? No. So make yourself a reference sheet. These are some of the formulas in 5-4 and 5-5 and 5-6. We're going to add more and more formulas. If you have a nice little sheet, you can use it. It'll make things easier. A nice little index card you put in your book. You can be studying them. Okay. So looking at all those formulas, what's something we probably want to do?
Cosine equals 1 over secant.
Oh, why are you doing that, Ricky? Most people would say secant is 1 over cosine. He's saying cosine is 1 over secant.
I don't know.
It's a good idea. Does anybody know why it's a good idea?
But we were just practicing. It equals secant.
Do you want to keep the secant?
Sure.
Now, do you have to keep the secant to end with the secant? No. You could have made him 1 over cosine, so I don't like secant. I'm going to get rid of him. Okay, cool. We could also say there's a secant to end with, so let's get rid of the cosine. Now, question, why could we not use the Pythagorean properties real fast? Some of you see the 1 minus, it's not squared. It's illegal. We can't use that. Okay? So what if we do change cosine to 1 over secant? Wait, Ricky, why on earth did you just say that's like what we were just doing? This has trig, it has variables. How on
The
earth?
same properties.
Oh my goodness. What is it? A complex fraction. Oh my goodness, what do we have to do? Simplify it? Oh. What's one way we could simplify it? Multiply. Now hold on. Eyes up. Eyes up, eyes up, eyes up. Couldn't we multiply this one, only him, by secant over secant and get this together? And we could write this as secant theta minus 1 over 1, and we'd have outer and inner. That's one way. What way would I suggest? I don't like having to rewrite it over and over again. I'm lazy. So I say, I just want to get rid of that little guy. He's in the way. How do we get rid of that little guy? Multiply top and bottom by all the little denominators in my way, which in this one is only the little baby secant. part algebraic what's about us in the sense that we put little parentheses because we need to distribute. Because we have multiple terms in the numerator and denominator. But do you guys see what I did and why I did it? Ew. Alright, fine. Multiplying top bottom. So what happens when we multiply top bottom? Start distributing now. Secant times secant, what can I make it?
Secant squared.
Secant squared. Minus secant times 1. Now some of you are like, ew, maybe we should have left it factored. Maybe we should have. But oh well, we're just distributing. We'll see if it works out or not in a second. What do we do in the denominator? Same thing. Focus just on the denominator. You have one expression, one binomial, times one monomial, just bring them in. Secant times 1. Secant over secant. Oh, booyah. I'm getting rid of that silly little denominator. It's just going to be minus 1. Oh, ew. Gross. That looks disgusting. Except, what could I have done instead of multiplying up top? I could have kept it in the factored form. And the factored form would look like, you see it?
Oh, I see.
So sometimes we don't want to distribute. I mean, we definitely did in the denominator because I definitely wanted to get rid of that little over secant thing about it. Ugh, I didn't like that. But in the numerator, if I leave it factored, now I can say, look at that whole denominator. That's a quantity, and now I have matching factors, top and bottom, that I can now. Dun, 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 dun.
Qued.
Yeah. QED. Quite, I feel like would have a U. I'm not quite sure. You want to put a check mark if you want to put a rainbow or a cloud, if you want to put a rubber ducky.
How would you enunciate QED?
You just need to put some sort of symbol that denotes for you. Ha-ha! I'm done. I've arrived. There it is.
No,
It's qued.
but there's no U.
It's
No, it can't be qued if there's no U.
Exactly.
Qued.
That's what.
English is dumb.
Ricky.
There's so many.
Plus it's an acronym. That's why I say
Ricky.
QED, like CIA instead of CIA.
Yeah, but it's for some.
What does qued stand for? Or can stand for?
Quote error demonstrative Latin for thus it has been proven.
Can we say thus it has been proven?
Yes.
Qued.
Oh, we didn't. Okay, let's go back and find it. JJ has an example that we were stuck on.
Can we say TIHP BP, please? Because that's
I think we did. Why don't you get us? You got it?
Let's do it.
I might have done it fast, but do you see I used Pythagorean?
And he fell
And
asleep twice.
hold on. Okay, get ready for a new example. We're just catching up on one of the ones we tried it.
Can I say TIHBP instead? Thus it has been proven.
Yes. You can do English instead of Latin. Not many people will understand. You could do a check mark too. You got it? Okay, new example. Come on, maybe it's not that bad. But on this one, we have to choose a side, and maybe different ones of you would choose different sides. We'll talk about which one I think I would choose. Really?
Actually,
I think I would choose the left.
because that's the Pythagorean.
From that perspective.
I think
Probably. But that doesn't mean that you couldn't choose the right. It just means it'd be more difficult to choose the right. We'll talk about that in a second. No, don't do both. You always need to stick to one.
I know.
But you could, on a scratch piece of paper, play around with the other side and see if you can make it match and then kind of work backwards. Does that make sense? That's a good strategy if you get stuck. And just a quick heads up, Honors did this before Christmas break. There were definitely some that worked really well through problems, but they had whole proofs that they had tried, totally crossed out, and they said, all right, let's go again. Let me try something different.
Did it take them 3 minutes before they gave up?
It took Sean Durkin, I think he worked on one for like an hour.
Was it possible? Or?
He kind of was going a harder way, there was an easier way, but he finally got there. Just took him a while. Poor Sean. He did a good job, though.
We're saying push on, he worked hard and achieved something.
But he achieved the Japanese work ethic in a actual way instead of a cheating way.
He's 1/32 Japanese.
All right, what do you guys think? Sometimes we should strategize a little bit before starting. I'm gonna see if I can do it. Shh. Okay, so the straight lines don't work. That's rough. Okay, if you were, wait. If you were to choose the right-hand side. If you were to choose the right-hand side, my question to you would be the following. What would you start by doing to the right-hand side? Yeah, I would think you can make it cosine squared with the Pythagorean. You can make it cosine squared with the Pythagorean. Then you would maybe figure out cosine over sine is cotangent. And then you'd have a 1 over sine. You would actually get cotangent, cosecant, and you would probably be stuck. And it wouldn't match. Now, why do you think I say let's choose the left-hand side? Yeah, it's kind of like there's something stuck here and there's something stuck here. And so I'm thinking maybe I have more to plug in for. I mean, I guess I could change sine to 1 over cosecant. Ugh. Maybe that would work. Maybe that would actually help me out. But instead of choosing, oh, I don't want that one. Sorry, it's loud. Didn't realize it was quite that loud. That's rough. Don't worry, just a smart board. No terrorist attack. Okay, so there we go. I'm gonna choose the left side. See, I'm just cheating. There we go. I'm gonna choose the left side. Now we have to still kind of figure out something to do, right? Any ideas?
Secant minus 1.
We can flip who? Okay, so Jason's thinking reciprocal identities. If you want to go look in the table at reciprocal identities, if that helps, section 5.1, flip back. We can flip, but in order to flip, I'm just going to go ahead and do it really legally. We can change cosecant of t to be 1 over sine of t, right? Don't judge my non-straight lines. 1 over sine of t. What do you guys want to do up here? Leave him, or maybe use a property for him too? Okay, we could make it 1 minus cosecant. No, it's cotangent. Careful. It's cotangent, not cosine. Okay, we could do cosecant squared minus 1. Can anybody think of anything else we could do? We could do cosine squared over sine squared. What sounds better? You guys choose. Cosecant squared minus 1 or cosine squared over sine squared. Okay, let's do, I like that one too just because it makes kind of everything in cosines and sines. Gives me that complex fraction. Yeah, right? And if you guys realize when we said just a second ago that this could be cosine squared over sine, maybe you're like, hey, this is looking good, right? Now, what do you guys want to do? Outer over inner, or do you want to do my snazzy common denominator trick? Okay. So common denominator, there's a sine here, there's a sine squared here. What do you think I'm going to multiply top and bottom by if it has to be the same? Sine squared. I need to get rid of everybody. So I'm going to do sine squared because that's the bigger, can I say bigger? The mightier of the two. So sine squared over sine squared. Sorry, my screen blipped out on me. Sine squared over sine squared. Technically, if you need to see it, they're technically over 1, if that helps. Just a few of you that might help you spatially figure out what's going on. What's going to happen up top? I just have cosine squared, right? What's going to happen on the bottom? Yeah. One of them go away, but I still have another remaining sign there, right? Oh my goodness, guys, how close are we right now? Check it out. We have the over sign. That's looking great. And cosine squared, I think this is a property, yeah? What makes cosine squared 1 minus sine squared? Just so we have a rationale as to why. The Pythagorean rearranged. You can go check it out if you want. To get cosine squared by itself, you would subtract. Ooh, I did a good one. 1 minus sine squared. From the Pythagorean property. Now, what's different in geometry? Or from geometry in the proofs we're doing? You don't have to tell me. Yeah, you don't have to state the rationale. Now, is it important to have a rationale? Yeah, because how are you going to keep it legal if you don't have a reason as to why? It's going to work out every now and then, but usually it's going to go awry. So, anyway, you need to have a rationale as to what you're using, why you're using, make sure it's legal. However, we don't have to be stating it one by one. Long story short, we get this guy and we say, hey, this has been proven. Uh-oh, this is going to be a bad picture. Oh, it turned out okay. We can go ahead and say check QED. Can we say KED? KED makes more sense.
No, it's not quid though. There's no U.
See? KED makes more sense.
I mean, technically,
Like the kids' shoes, but without a K. Anyway. How you guys doing? Still alive? Give me a thumbs up if you're like, I think I kind of followed it. Okay. How many of you guys at least are like, I see that you're plugging in legal properties? Okay. Tyler.
How'd you move from like the first to second? How'd you move from a cotangent to a cosine?
Oh, okay. Because remember, cotangent alone, not squared. Cotangent alone of x or t or u or whatever. From the quotient property, cotangent of t equals cosine over sine. So if I have a cotangent times cotangent, I can do a cosine over sine times a cosine over sine, and they end up both squared. So I use the quotient property, and then I square the quotient property both sides. Does that make sense? Yeah. So just because you see a square doesn't mean you have to use Pythagorean. You can use another property and then just square it and use that instead. Does that make sense? Austin?
The denominator?
Yeah.
What's the sine t?
Uh-huh.
Why is it like, say, squared on the left?
Oh, the reason remember, you have to multiply top and bottom by the exact same thing to keep it legal and balanced. So since there was a sine squared up top I wanted to get rid of, I chose to multiply top and bottom by him. Because I will get rid of that one and get rid of that one. I just have a remaining piece on the bottom. Does that make sense? So it's kind of like if you have something like 1/2 plus 1/4, you'll multiply by 4 over 4, not by 2 over 2. Is that kind of? All right. Okay, guys, remember, we're doing tons of examples to try to prepare you for homework, because I just want to give you lots of examples of different things you may see. Different math you may be required to do. Practice on choosing sides, plugging in. So please, please, please have your notes and have your formulas nearby when you do this homework. I'm doing these examples on purpose. Nathan?
Obviously, you choose the left side here, but
Yeah.
would it actually be possible if you choose the right side?
Here's the problem. If you choose the simpler one, you probably have to introduce something yourself in order to be able to make it to work. For instance, on the other side,
Let's do it.
some of you guys just write down the problem. Just ignore what I'm about to say. But you could make this 2 over cosine. You could look over here and see the 1 plus sign and say, well, I want a 1 plus sign. Sweet, let's multiply top and bottom by 1 plus sign. You have to put it in yourself and then kind of play with it and see if you can get it to work.
Let's do it.
Let's do it. Not right this second. Maybe tomorrow when we're like doing the last day of examples, I'll do some fun with.
With hard problems, making it acceptable.
Doing it the hard way. With doing it the hard way. Okay. Are my lines better? That's right. Okay, it's gonna be a loud noise. Don't think about it. I'm choosing the left. We're all choosing the left, right? Just kidding. Correct? Okay, question. Math. Do we start with some math? Is there some math we can do, or properties? What do you think?
I feel like there is some math there.
The reason I'm basically balking at the property thing is because what property would we do? I don't know. I think you guys see the secant and you're like, hey, let's make them 1 over secant, 1 over secant. We can't distribute yet because there's an addition. And we can't add yet because they have different I would do common denominators. Otherwise, you could do properties, but you would make some nasty complex fractions and they're being added. You can do that. I would probably say it's already all in sines and cosines. Let's see if there's some math to be done. There's a plus that I need to join into one expression. You guys see how this one's a binomial, 2 pieces, 2 terms. This one is a monomial, so we got to get this together. How do I get a common denominator? No good shortcut necessarily on this one, guys. What does this fraction need? Him. Yeah, he needs the other denominator. However, this guy needs some more in his denominator as well, right? So they both need some extra pieces. You know what, let me use the snipping tool. That'll be easier. And it won't kill your ears every time I use it. You're welcome. If he actually opens. Okay. So I'm stealing that. This, you guys can literally see what I'm doing because I'm going to steal this 1 plus sign. Because I need that to be a part, since he's that denominator, I need him to be a part over here. So I have 1 plus sign over 1 plus sign. I'm going to steal the cosine from this fraction, quite literally. Remember, we have to do same top and bottom just because that's the only way to keep these balanced. Now, hold on. We're good algebraic kids, right? So we remember that there are parentheses around all these guys, yeah? Got to keep it legal, otherwise we're going to end up not distributing when we need to. Now we have some options. We need to basically, I don't remember what I had before. There we go. We want to get this all in one nice big fraction. True? Okay. We have a common denominator. Question, for these denominators, do we need to distribute the cosine in? Or could we keep it factored? Okay, let me go ahead and keep it factored just because if you guys can tell, there's a little too much in this problem, meaning I'm hoping some stuff cancels out, yeah? I'm hoping some stuff cancels out. So let's go ahead and get both of these guys. Now we're going to be good algebraic kids and we're going to make sure that we have those parentheses still. Otherwise, if you write it like this, you're going to get confused. So let's make sure we have those parentheses. If you want, you can put parentheses around cosine. He's his own little dude, but that's okay. What are we going to do up top? Leave it. We want to get rid of a lot of that stuff, right? Hopefully with properties. How do we legally multiply these two? 1 plus sine squared? No. What's the only legal way to go? We got a FOIL. Not impossible though, because 1 times 1 is, well, that's not bad. The outer is 1 sine, the inner is another sine. What's 1 sine plus 1 sine? Mm-hmm. Don't forget your thetas. Make sure you have your arguments. What's the last going to be? Sine times sine is? Now we've finished with that one on the left as I finish writing the sine squared. Question. What do I have from the right expression? Cosine squared. Ooh, cosine squared plus sine squared is 1. So I can take this entire piece and say, hey, bless you. So you're 1 from the Pythagorean property, right? And it's plus 1. So I can take this whole part and say, no, you're Pythagorean property. I can just make you plus 1. What's 1 plus 1? 2. Ah, do you see how there's 2's now in both parts? 2 plus 2 sine. Can I pull out a 2? So I had 2 there. I need to hold that place. I have a 2 in front of the sine of theta. My guys off to the side, help me out, please. Don't make me come wheeling over just to stare you down. As fun as that would not be. Now what can I do? Yeah, do you see why it was nice to keep everything all factored? Could you have multiplied? Yeah, totally. You would have just had to factor in the next step. So sometimes keeping it factored is nice, because now I have common factors. I see 2 over cosine. I look at the end and say, oh yeah, that's right. 1 over cosine is the exact same thing as 2 secant. At this point, I can say the left side matches the right side. Since the left side matches the right side, check QED. Struggle. We are done. Now, kiddos, let me just warn you of a few things, because we're almost there as far as chapel time. We are still doing some more examples tomorrow, but pause. Some of you are going to have a false security saying, oh, it didn't look that bad when she was doing it. This is one of the most common sections for kiddos to be like, it was so much better when we were doing it with you. I know, because I know the direction to lead you. Tonight, when you guys start homework, as you need to, please, 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 it's a long section. As you start homework, have your formulas, have your notes, look for similarities of procedures, processes, ways, directions I went when a problem looked a certain direction or a certain way, and try to copy it. You don't have to do it all alone. CalcChat is not necessarily the best way to do this homework. You can kind of check it, but they show things differently. They don't show the T, they kind of just show lots of equals, and it gets really confusing really fast, and they skip steps because they're smart, like math grad students that did it. So, please, 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 have the notes, have the formulas, do your best. The biggest thing is grit, perseverance. Try something.
Stick-to-itiveness.
Chapel schedule, stick-to-itiveness. Exactly. You guys have 30 seconds.
At least stand in proud of the like you're doing.
Happy Monday. Did we all survive the weekend?
I mean,
How many of you guys got sleep?
Oh, I slept.
That's it? You guys had to catch up. Last week you got tired. All right. Are people walking? Little cheaters because there's no bell. All right, fine. Imaginary bell. Beep. We get out early. Bye, guys. See you later. Bye. Don't slip in the rain.
I know. When I got home from the game, I